So if we're talking about a process of liquid turning into solid, solids into liquid, all this kind of jazz, with these phase changes, it all takes energy. So the next logical thing to talk about is what's energy? How do we talk about energy? How do we define energy? How do we use energy? So let's talk about that. So energy is defined as the potential or the capacity to do work or produce heat. Now, potential or capacity means can it do it, right? So if something can produce work or heat, then that must have a lot of energy, okay? Now, producing work is more of a physics kind of an idea. So doing work is like lifting, pulling, some mechanical process. Heat production is energy being evolved, right? Electromagnetic radiation, infrared, and so on and so forth. Um, so when we talk about energy, what kind of energies are there? And I think you're familiar with these energies. You just don't necessarily think of them because this is new. So kinetic energy was defined as the energy of motion. So when something has motion, it has energy. And if you give something energy, sometimes you can give it motion, right? That's what happens when we play sports, where you throw a ball, you kick a ball, and so on and so forth. You give energy to it, and it moves and it flies. So that's what kinetic energy is. And it's calculated using this equation. We're not going to calculate anything in this class with kinetic energy, but just so that you're familiar, I want you to see what it is. Is that equal to 1/2 the mass times the velocity squared? Now, the mass, the more mass there is in an object, the more kinetic energy it has. So if I take a tennis ball and I just drop it and it hits you in the foot, there you go. Ooh, what hit my foot? A tennis ball. If I take a bowling ball and I drop it and I drop it on your foot, you're going to notice. It's going to hurt. Why? It has more mass. If I take a tennis ball and I just let go and let gravity pull on it and hit you in the foot, you go, hey, what was that? Boom. If I take a tennis ball and I shoot it out of a cannon and I hit you in the foot, you're going to notice it much more. So velocity, how fast it's going and how much mass there is, has a lot to do with the kinetic energy. That's why car accidents create such damage, because there's so much mass to them. So that's one kind of energy. The other kind of energy is what's called potential energy. Potential energy is the energy that's due to an object's vertical position, how high it is. And the higher it is, the more gravity pulls on it. And the equation is mass times g times h. H is the height and g is the acceleration of gravity. So it has to do with gravity. So the more mass something has, obviously, if I drop, again, a bowling ball versus a tennis ball, it's got more mass, it's going to have more potential energy. If I drop a tennis ball from a higher height, when it hits you in the head, it's going to hurt more, right? It's going to have more energy transferred to you. So that's kinetic energy, and that's potential energy. So kinetic energy is the energy of motion, and potential energy has to do with its vertical position, okay? So we have those two. Now, the unit that's used to describe energy is the unit of joule. Joule. He was a French scientist, and that's the SI unit that's used. The non-SI unit, the more common kind that's not necessarily scientific, is the calorie, which we are familiar with because it's related to the food calories. And the relationship between a calorie and a joule is 4.184 joules in a calorie. Okay, so that's the relationship between those two. In the next video, we'll talk about how we do and deal with that.